log linear modeling. Example 1, we have the number of bacteria N present after T hours, given by this relationship. Here is some experimental data giving values for T and N. So, for example, when T equals 8, N equals 768, which is this point on the graph, and plotted on this scatter graph, we can see that we have a non-linear relationship between N and T. And N and T are related by this formula. Now let's pretend we don't know the constants, the 3 and the 2. Let's remove them and replace them with constants K and B. So now we have to find the constants K and B using this data. So method 1, we start off by taking logs on each side and using some of the laws of logs, and then rearrange our terms into a form that matches up with y equals mx plus c. Now y and x are variables. Log n is a variable and t is a variable. M and c are constants. Log b is a constant and log k is a constant, because the b and the k here are constants. So on the y-axis we plot log n, on the x-axis we plot t, the intercept is log k, and the gradient is log b. And remember, b is a constant, so log b is a constant, so the gradient log b is a constant, and a constant gradient gives rise to a straight line graph, a linear graph. And this is why this topic is called log linear modeling. So if the graph is log n versus t, in our data we need to calculate some log n values, like this. So we put the highlighted data here into the calculator, and we get the intercept and gradient of our straight line. Intercept, gradient. Now the intercept is log k, and that's equal to this value, and the gradient is log b, which is equal to this value. So we write down some simple equations for each one, and we solve to work out the constant k and the constant b. And we're doing 10 to the power of in each one, because the base here for the log is 10. And then we substitute our values in, and we've got the relationship between t and n. Now this method is the very long version and highly unlikely to turn up in an exam question. There are just simply too many calculations to do. A shorter version of method 1 is where this graph and its intercept and gradient are already given. So you start off by taking logs, and then again you identify that the intercept on your graph is equal to this value, and you solve to work out k, and that your gradient is this value, and you solve to work out b, and then you substitute your values in to get the relationship between t and n. So once again, in this method you must be able to take logs and know how to rearrange your terms into the y equals mx plus c structure. Now in method 3 we use something called coding, also known as change of variable. So we're going to replace log n with y, the change of variable, and we replace the t with x, again change of variable. This is called coding. So we use these. So this will be y and this will be x. So we get this. And the intercept and gradient are either given on a graph, or the equation of this regression line is given. This is how method 3 starts. You don't start by taking any logs this time. You're just given the coding and you're given the equation of the regression line. So we have to decode the data to go back to the original variables n and t. So start off by replacing the y with log n and replace the x with t. The log here is to the base 10. To get rid of the log terms from the equation, we do 10 to the power of on each side, because you have a function and its inverse here. So these cancel to give us n on the left hand side. On the right hand side, using some basic laws of indices, when you're adding indices, it just means you are multiplying terms. These two are multiplied, they're still multiplied. We do the bit in the brackets first to simplify. We simplify the term here, and this gives us 2, so it's 2 to the power of t, which means we've worked out our constants. Most of the problems in the textbook are like this. They start off by giving you the coding, and they give you the equation of the regression line, and then you decode the data by following this method, and you're doing 10 to the power of to get rid of the log term. You play around with your indices and you work out the constants.